Hello, welcome once again. Dealing with problems with fuel injector problems, especially codes when you get off scanners or code readers. Sometimes it gives you an individual cylinder. Cylinder number 3 has a problem with fuel injector or resistance or things like that. First, in order to understand what's going on, we have to understand the basics of fuel injectors, which I went over a couple of times. There is a manual, obviously. This manual, the dealership manual, which I've used, and if you're going to go by this standard of using this type of manuals, it's very confusing, it's very technical to troubleshoot something with a code. And even if you go through it, if you make one mistake by going with one step, which you shouldn't have, you'll end up going through the wrong steps and misdiagnosing. So this type of diagnosing, troubleshooting, is very technical. And the reason I brought it up was because someone asked a question about relating to this type of material. But first, let's understand fuel injectors. You can think of a fuel injector in the simplest form. Think of it as a valve that opens and closes, which lets fuel go through each cylinder. Now, since we're talking about fuel injection, okay, we're talking about something electrical. Now, the connector is here in the simplest form that I can show you. The connector is here. We have two connections. One is going to be, let's say, 12 volts, and the other one will be a ground. So remember, always two connections to every component. Ignition coils, fuel pumps, they always have to have two common things. That is a voltage, a B+, this is considered a B+, and a ground return back to the battery. This 12 volts and ground allows this to open, to allow fuel to go into the proper cylinder as much as is needed. If you want to understand it, think of it as a faucet, and I always explain faucet in a kitchen. The more you open up the faucet, the more water will come out. The less you open up the faucet, the less the water will come out. So is this. However, we don't do this manually. We give the ground to a computer, a PCM or ECM or ECU. We let the computer handle its business of opening and closing the valve, or increasing or decreasing the time that this is on in milliseconds. The more air, the more fuel. The less air, the less fuel. The computer has command of the ground. We'll show you the diagram, but first you have to understand the basics. Okay? So again, fuel is coming in. Intake valve is open. It allows air to come in. Now the fuel is ready to be submitted into the cylinder. Okay, now here's the difficult part when you get codes. Let's say you get a code for the fuel injector and you think it's a fuel injector or you're not sure. Now, what do? The difficult part with fuel injectors is there's a spray that comes out, a mist. Okay, we want it to be a fine mist that comes out. This is in the cylinder itself. This fuel injector, what comes out of this is in the fuel injector, is in the cylinder of each cylinder in the engine. We cannot see in this if this spray or this mist is a fine spray or if less is coming out. We cannot see such a thing because why? It's closed in a cylinder. Compression and combustion is taking place. That's the difficult part. If you turn on your faucet in the kitchen, you can see how much water is coming out the faucet. If not enough water is coming out, you know you have a problem with the valve or the line or the faucet. We don't have that luxury when it comes to fuel injectors. So we can't tell just because the computer gives the command to open it that enough fuel is being sprayed into the cylinder. Thereby, that's the most difficult part for us, how to diagnose something like that. We're not visual able to see that. Okay? Certain methods are that you can do that. Now, if you get a code, let's say, for a certain cylinder, as like I was saying, cylinder 3, cylinder 4, and a fuel injector is involved, how do you go about it? Okay? Like I said before, you cannot go through this unless you're really technical and professional as myself and other ones to go through the steps of a dealership manual. Just go to the schematic and we'll find out what's going on. Okay? So let's go to the schematic and we'll find out what's going on. Now, when we go to schematic, let's use this, what we just learned here. We know we need a 12 volts. We know we need a computer. We know we need a ground. Who's going to be in charge of toggling, we say, the ground? The PCM. Let's see if this is true. Here we have a schematic. So if this is your first time ever coming to this channel and you're not familiar at all with diagrams or schematics, but there is a code. You put the code reader. You got a code for a certain cylinder. Okay? Let's say cylinder number 3, let's say. Okay? You're not sure if I do have to change the fuel injector. Now keep in mind fuel injectors are expensive. Okay? Keep in mind another thing. We can't go and take apart many components until we get to a fuel injector itself with GMs, V6s, V8s. It's not that easy. A lot of things have to come off before you actually get to the fuel injectors themselves. On a 4-cylinder, you could get to the ignition coils. You could get to the fuel injectors. It's right there at the front. However, dealing with anything that's a V, V6, V8, it's a tough task. You have to take off EGR valves, vacuum lines, PCV valves, EGR pipes, or intake manifold. It's a long process just to get to a fuel injector, especially with GMs. And once you take out all that, you have to replace the component. You can't just put everything back another hour and charge the customer 2 hours and say, I don't think that was the problem. You can't do that. Once you take apart, you replace that component with another component. You have to make sure. So, your first time ever in this channel, and you're saying, what is schematic going to help me troubleshoot a code that I got? I'll just go to AutoZone and pick up a fuel injector, if you can get to the fuel injector. If you can replace it. It's not that easy. Now, you've never seen this before in your life, a diagram. Anything has to go through a fuse, okay? The fuse always has a rating of 10 amps, okay? We have a problem with getting a code to fuel injector 3. We want to know, is the fuse involved? We know the code only gives us for cylinder 3. What does that tell you off the bat? That tells you that the other 3 ones are good. Can a fuse be a problem? No, because then if the fuse would be blown, all 4 of them, all the fuel injectors would not be spraying fuel. They would be off, in the off state. So it can't be that the common cause is a fuse. So we have 12 volts here. We have current flowing through here, coming through here, going through this wire, a gray wire, a pink wire actually, a gray over here. This is a connector, pink here, gray here, okay? So we started out from the battery through the fuse, 12 volts here, coming through here, coming through here. This is a splice, a common point for many wires to be connected. It's called a splice, S128. So we come over here. It goes to where? Fuel injector number 1, a wire connected to that one. Another wire is connected to where? To fuel injector number 2. Another wire connected to fuel injector number 3. And another wire connected to what? Fuel injector number 4. So 4 gray wires. So if I ask you the question, those taking the ASC certification, is this the diagram for a V6, for a V8, or a 4-cylinder? It can only be the diagram for a 4-cylinder. Why? Because there are only 4 fuel injectors. A V8 does not use only 4 fuel injectors. It uses 8. Then you would see 8. A V6 uses 6. It would be 6. So this diagram is only for a 4-cylinder. We needed 2 things, 2 variables. What did we say? We said we needed 12 volts. We needed 12 volts, which we have. We need a ground and a computer. So we have 12 volts coming in where? Through this fuse, ECM fuse, right? Notice the fuse doesn't say fuel injector fuse. It says ECM. Why? One side we said we need 12 volts, okay? Through all these gray wires. The other side, black wires. Here's a black wire going to ground, a black wire going to ground, a black wire, a green and black wire with a black stripe, a pink and black stripe wire, and a blue and black stripe wire going to ground. Correct? So we said two things: a ground, a B plus. We have the B plus. Here's the 12 volts. Okay? We need the ground. PCM. Remember, I asked you, why is this fuse called ECM and not fuel injector? Because ECM controls it. A ground could go physically to ground. How do I know? If this would be G103, G104, G105, I know it's going to physical ground. In this, the computer has control of the ground, like we just said before. So we just proved what we said before in the diagram, in the pictorial. We need 12 volts to each injector, always. Remember the connector. One is for 12 volts, one is for ground. However, the ground is what? Controlled by the computer. The computer will turn this on when it's needed to give more fuel for each cylinder. The rate that it's going to turn it on, in other words, in milliseconds, 8 milliseconds, 4 milliseconds, is determined by the air-fuel ratio, how long it needs more fuel. The oxygen sensor gives all that information of the output of what's coming out of the engine. And the computer is always controlling to give more fuel or less fuel. It depends if you have, obviously, sequential or if you have port fuel injection. It depends what you have. So in this state of mind over here that we have now, we have a code fault for fuel injector. We're dealing with this one. Now, the computer will turn this on and say, I will close this. How? There's an internal transistor in here. That's a transistor, base, collector, emitter. This is acting as a switch. Transistors can act as an amplifier, current gain, voltage gain, power gain. Not in this situation. It is acting like a switch in saturation. Okay? Forward bias here, and this becomes a switch. It's like closing a switch here. I don't want to get too technical about transistor. It's not the video about that. But anyway, it can happen that this switch is shorted, and this will be on all the time. But if we're talking about port fuel injection, that means that 3 or 4 injectors are connected together at the same time to one common transistor, and then all 3 will be involved. Now, here's the problem. If we get a fuel injection code like we got, I take the connector out. Here's the connector. It's connected to, let's say, a wire. Okay? It's connected to, let's say, a gray wire and a pink wire. I take the connector out. Why? I measure 12. Instead of measure 12 volts, I measure 8 volts in the circuit. What do I do right away if I measure 8 volts or 10 volts? That means something is pulling this down. But the reason why I went to this schematic, first you have to understand this, the fundamentals before we go out and do hands-on. You could think of it as a parallel circuit. Okay? Everything has the same voltage. Okay? So therefore, if let's say I have a code for this, it will go down to 10 volts. Guess what? All of these will be now 10 volts. Why? Because they are in parallel. 10 volts here, 10 volts here, 10 volts here, 10 volts here, 10 volts through the fuse to the other side. Now everything is being pulled down. However, our code only tells us fuel injector number 3. Since it's only fuel injector number 3, I take that theory out of my mind that something is being pulled down. Now, can it be that fuel injector number 3 is not being turned on by the computer? Of course it can be. Okay? That could be also. Can it be that the fuel injector is dirty or clogged? Just like when you open up the valve, I return to that theory again. You open up the valve of the faucet in your sink, nothing comes out, right? Computer turns on the fuel injector, nothing comes out. First thing, what should I do is, I think I don't have 12 volts. What should I think? Nothing is being pulled down. what about this wire? If this wire is broken, how about the individual wire in a parallel circuit being broken? If this is broken, there's 4 wires, and this wire is broken, I have what? 0 volts, 12 volts. I have nothing turning on the fuel injector. I have less fuel being omitted to the exhaust, which comes out to the oxygen sensor, which tells it, you know what? You're going lean. You're not rich. You have less fuel, more air, parts air than less fuel. So I think maybe this is the problem. First thing is I will measure 12 volts. Make sure that this is not broken. Okay, like I said, when I get the chance, I'll show you the hands-on. Right now, I want you to understand the theory. So if that's not the problem, fuel injector, maybe this is not closed. Can I take this and put this to a ground? But remember, you have to have a pulsation. You have to have it being pulsed on and off, not just putting it to ground. Can this be dirty or clogged? Can one fuel injector being dirty, or are they all dirty or clogged? Well, look at the mileage of your car. If you're over 100,000 miles, you should have had your first tune-up by now, which means they put a fuel injector cleaner to your rail to clean out the fuel injectors. The problem is, I do not know, even if I have 12 volts and this is giving the proper ground pulsations, I do not know how much is coming out, how much is being sprayed. Like I said, that's the problem. Can you do an injector balance test? Yes, you can do that. How are you going to get to those parts if they are buried in? And it's hard to take everything apart. Go to a scanner. Not everybody has a scanner. So that's why I'm running through every basic thing to tell you it's not that easy. It's just not that easy when it comes to V6s, V8s. Okay, when you have a code. Can this be a misfire? What's a misfire? A fuel injector misfire means either I have no spark from an ignition coil or a spark plug wire, or I'm missing fuel. Why am I missing fuel? Maybe there's no 12 volts, or bad compression. What's the symptom of a misfire? Well, usually when you have a misfire, the engine, as soon as you turn it on, you'll see a vibration, a shaking. You'll feel that vibration. Okay? Now, even at idle. Now, if you put the air conditioner on, you'll feel it even more. Why? Because you're putting the compressor on. The compressor is a load on the engine. It'll make it work harder. That means you'll feel more vibration. If you're at a stop sign or a light, a red light, or you're in traffic, you'll feel the vibration once you're in drive mode because you're idling. You might stall. So what do? You put in neutral, okay, for that time so it doesn't stall. So that's a symptom of misfires, a vibration, a shaking from the engine, and you'll feel it in the steering wheel. Or not always in the steering wheel, but you'll feel it in the front end. So that's one of the problems that we're faced with. Can it be the computer? Yes, it can. Can it be the 12 volts that's not? Yes, it can. Can it be the fuel injector itself? Yes, it can. But the code did not tell us misfire. It just told us a resistance test or with a fuel injector number 3. Can we be running lean? That means we have less fuel. The oxygen sensor tells us we're running lean. We have too much air, too little fuel. Can it be rich? We're running too much fuel, too little air. No, it can't be that. So whatever comes out from the engine to the exhaust to the catalytic converter, and the oxygen sensor detects, hey, we're running too rich. That means there's too much fuel. Can it mean that a fuel injector is leaking, just like the faucet in your sink is leaking sometimes? It can, but then you would be rich. So I'm just going through every synopsis of what is possible to be done. But overall, look at the mileage, if it's worthy to do a fuel injector cleaning. Look at if it's able, because these are very expensive. Usually they're changed in pairs. You don't want to spend $400, $300 on injectors if it's not needed. So try, obviously, the fuel injector cleaning, but also make sure you have 12 volts going in here. This is the hard part of the computer grounding it. Once you go through these 2 steps, if nothing else is it, you can say to yourself, okay, the power control module has a problem, but make sure that this is not open. The pink and black wire is not open. It's making a connection from here to here. As I said, I will demonstrate these things when I get a chance. I haven't been making so many videos. I don't upload as much as I used to. I have too many projects going on. But when I get to that chance, you'll understand, hopefully, after this. So again, in review, a fuel injector needs a positive 12 volts. If you have a misfire, this 12 volts will now read whatever the alternator is giving it. So you might read 14 volts, right? Because the engine is working, the alternator is working, but we have a misfire. So you always go through, I need 12 volts through anything, a fuel pump, ignition coil, anything needs 12 volts, and it needs a ground returned back to the battery. That ground could be a physical ground, or it could be a computer toggling on and off, more milliseconds or less milliseconds. I know this is confusing, but you go by the codes and you go by a schematic. That's the easiest thing to do. So I hope this was informative. The hands-on will come on, but you'll understand it much better after you saw this. So thanks, and please subscribe. Thanks for watching.